Hi everyone, I'm Adam Horvitz, and today I'm going to walk you through my infographic, The Future of Software Engineering in the Cloud. So in just 5 minutes, we'll explore how virtualization, containers like Docker, and service models such as IaaS, PaaS, and SaaS are shaping the future of software engineering. So let's dive right in. So to start, we're going to talk about the problem formulation. So this topic comes from chapter 19 of the Somerville textbook, and it focuses on how cloud computing supports scalable and efficient software delivery. I chose this because cloud infrastructure is now everywhere, from Netflix streaming to Spotify music. So for scope, I focused on three areas: virtualization, service models, and real-world applications. What I exclude are things like cloud pricing models or deep dive into private cloud configurations. We're sticking with the tech that powers modern apps. So let's talk about the literature search. To support, so, to support this research, I reviewed three peer-reviewed studies. David Bernstein, who introduced Docker and Kubernetes as cloud-native game changers. Felter et al., who compared virtual machines and containers. They found that containers delivered near native performance, which is impressive given how just lightweight they are. And a 2024 paper by Al Harty, which looked into auto scaling techniques and how cloud platforms are learning to predict demand before it spikes. These articles help me understand not just what cloud platforms do, but how they do it. So we're going to go into the critical analysis, talking about VMs and containers. So here's what really stood out during my analysis. Virtual machines are great for isolation, but they're bulky. Containers, on the other hand, are fast, portable, and they let you deploy apps anywhere in seconds. Autoscaling is a major strength of the cloud, but it depends heavily on predicting workloads accurately. Otherwise, you're either overpaying or underperforming. And when choosing between IaaS, PaaS, and SaaS, it really depends on how much control you need. IaaS gives you the most flexibility, SaaS gives you zero maintenance, and PaaS is right there in the middle. So in my research, I also uncovered that over 80% of companies use multi-cloud strategies. So they don't rely on one service provider or another. This helps in situations like downtimes or even monopoly. So what does it mean exactly? What does this mean for the future software engineers like us? Well, cloud computing accelerates innovation. With microservices and CI/CD, we can push code daily or even hourly. With services like Docker or Kubernetes, we can scale apps around the world automatically. This means less time on infrastructure and more time building great software. The takeaway, knowing how to work with containers, cloud APIs, and deployment tools is now a core skill, not just a bonus. All right, so let's talk about the coolest part I found, which is cloud native innovation. What fascinated me in the most was how tools like Kubernetes and AWS Lambda make it possible to run code with no server management at all. You can deploy an app that scales globally, reacts to user traffic in real time, and costs just nothing when idle. That's not just efficient, that's transformative. It's a whole new way of thinking about software delivery. No more monoliths, no more downtime for maintenance, just fast, elastic code on demand. So, like I said here, this modular, elastic design is the new normal. So, I'm going to go over my references. To wrap up, cloud computing is more than just a buzzword. It's a toolkit that's transforming software engineering from virtual machines to containers, from IS to serverless. It's changing how we build and scale apps. Thanks again for watching. My name is Adam Horvitz, and this is my research on cloud software engineering. Don't forget to check out the full infographic and the research papers I referenced here. So here's the full infographic, and I'm also going to publish a link in the description as well. Bye.